Confidence interval is another way of expressing precision that's actually more common in analytical chemistry. And what it does is says that if there's no determinant error involved, and if we have a normal distribution, then we can be usually 95% confident that a value is within a certain range. So the way you calculate a confidence interval, if we have a series of numbers, let's say we're looking at milligrams per liter of calcium, and we have 5 values: 8.92, 9.17, 8.91, 9.02, and 9.16. The first thing you want to do if you have a set of data is come up with, state the number of observations, and you can just count them. So we know we have 5 in this case. And then usually with a calculator or some kind of spreadsheet program, we would come up with the mean value for the sample and the standard deviation for the sample. In this case, the mean is 0.036 milligrams per liter, and the standard deviation is 0.125 milligrams per liter. Once you have those values, we can plug it into the confidence interval equation. And the confidence interval equation says that the true value, or the population mean, is the sample mean plus or minus the confidence interval, which is this value of t, which we have to look up, times the standard deviation divided by the square root of the number of values, number of observations. So we can plug numbers into here. We know our mean is 9.036 plus or minus the value of t we have to look up. So we go to a table, it's called a student t table, and make sure we look up for 95% confidence. It's sometimes called alpha 0.05, and we need degrees of freedom. The degree of freedom is n-1 for a set of data. So we have 5 measurements, so degrees of freedom are actually 4. So we look up for 4 degrees of freedom. When we do that, 95% confidence, 4 degrees of freedom is 2.776. And multiply that by standard deviation, 0.125, and divide that by the square root of the number of observations, which is 5. And you end up with a value of, well, we have the mean, which is 9.036 plus or minus 0.15573. And we normally round the error, round the value of the precision down to 1 or 2 significant figures. If you do it to 2 figs, then that will be 0.15, and you make sure that the mean value is to the same number of decimal places. So this would be 0.04 plus or minus 0.15, or 6 if you round up. I guess really that should be a 6. Milligrams per liter of calcium. So that's saying that we're 95% confident that the true value is between 9.04 minus 0.16 and 9.04 plus 0.16.